Welcome back. So during this lecture we are going to focus on another interesting array based algorithm where we find the maximum or minimum value stored in the array. Okay. So when we talk about maximum and minimum value, so for numbers we know that it's a numerical value, but it can be strings, so it can be characters, or it can be our own objects that we store in the array. Now in case of a string, we can determine the maximum and minimum based on perhaps the length of the string, or maybe lexicographical order of the characters. So and for an object, so it really depends on what quantity in the object that determine whether that particular object has a higher value or a smaller value. All right. So then the basic algorithm that we are discussing can be applied across many data types that we would store in an algorithm, in an array. But here we essentially focus on numbers to get the idea of the basic minimum and maximum finding algorithm. All right. Okay. So first of all, then when you want to do the minimum and maximum finding, so and the application of that, so minimum and maximum finding is sometimes pretty useful in searching and sorting operations that we usually do within array operations. All right. So sometimes we need to search for the minimum value, or maybe search for the maximum value, or search for a certain value. So then minimum and maximum finding can be applied in searching. Likewise, when you are sorting data stored in an array, so essentially finding the minimum and maximum is needed, so in order for us to organize values in the sorted order, right? So as we discussed then, so first we'll talk about integer values, and then obviously we can apply those things into strings and objects and any other data types also that we store in the array. All right. Now first, so let's take a look at the maximum finding algorithm and then see what the basic approach is. So taking an example, so suppose we want to develop a program that read 10 integers from the keyboard and then store them in an array. So then find the largest element stored in the array. Right? Now here the basic idea is something like this. Okay? So if you have an array of, let's say 10 elements in this scenario, it can be n elements in general, right? So now I have let's say elements like 1, 15, 100 and so on and so forth, right? Now in order for me to figure out so what is the largest value stored in this array, so we need to pretty much scan through the array and then pick the largest. Now when you scan through this, so when you program it, so we need to do it in more ordered fashion so that the algorithm is unambiguous. So therefore we need to specify where do we start the scanning process. So one of the most possible starting points would be the first element of the array. So then we can assume that the first element is the largest value stored in the array, and then so we can compare that element with rest of the elements in the sequential order. All right. So then for example, let's say x, we assign it to the maximum, so that's the first element, and then we can going to compare x with the second element, third element, and so on and so forth. So next element until we find a larger one than the current largest. Now in this case, for example, when you compare x, that's 2 with 1, so 2 is still larger, so then no change. But when you compare x with 15, so we know that 15 is larger than the current maximum, that is 2. So then we change value of current maximum 2 with the new value that we found, 15. So as you scan through this array, so then in the end, so we will have x with the largest value stored in the array. So therefore what we had to do is then, so we access the next element, compare it with the current maximum. If the current maximum is smaller than the next element that we are comparing, so then make the next element the current maximum. So that's pretty much the repetition that we need to do over and over again until we are done by comparing all the elements with the current maximum, right? So after doing this process, so then current maximum is going to have the largest value stored. Sometimes not only we need to find the largest value, but also we need to find the location at which we find the largest value also. Now if I want to kind of keep that value as well, so then we can have a variable called max, let's say index. So then initial value for the max index is going to be 0 to indicate that we assume that the first element is a maximum, and then as we change the current maximum in step 2, so we can change the corresponding index value as well. So in that way, not only we find the maximum value, but also we find the location at which we find the maximum value as well. Okay, all right. So let's get a simple example where we are going to store, let's say, some integer values in an array, so 10 of them. Okay, and we need to find out what is the largest value stored in the array. Now the first thing we do is to read data from the keyboard and then store them in the array, and based on our assumption, so we assume that the first element is the largest. So then we get the max index and assign it to be 0, right? So then in the maximum finding loop, so what we do is start from the second element until we are done searching all the elements. So what we do is we check if the current maximum, so max index location value, is smaller than the ith location that we are just comparing. So if the ith location that we are just comparing has a higher value, then we know that the max index has to be I. So that means that we found a higher value in the ith location. So then we change the max index to I. So once you scan through this process and then run through this for loop, so max index is going to hold the location at which we find the largest value. So then we can use that index to get the value by using int array max index. So that's pretty much going to give us the maximum value. So the benefit of using the index is that not only we get the maximum value, but also we find the location at which we find the maximum value. So that information will be useful in subsequent computations in the program. So in general then, so we find the location at which we find the largest value, right? Now obviously this algorithm works pretty well. So if there are no duplicates in the array, so if there are duplicates where we can have more than one maximum value, so in that case we might need to change the algorithm to find out how many such values are in the array, and then report that value also. And also we might need to create an array of max indexes where we store those maximum values stored in the array as well. So that can be addressed by having then multiple max index locations stored during the process, right? So now let's try to apply this concept in solving a simple problem, right? So suppose we need to write a C++ program that reads names of 5 cities and corresponding city populations, and then so we need to find the name of the city with largest population and then display name of the city and the city population, right? So now if I want to do it, so this problem is slightly different than the previous one that we talked about. In the previous one we had only one array with numbers, but in this scenario so we have two arrays. So one with strings, so that's the city name has to be a string, and then we have the integer value with the city population, right? So then if we draw the diagram to explain how this problem works, so then we will have one array, so that's going to be actually a string array. So let's say city name, right? So this can be size actually 5, so then new string 5. So we can assign array like this, and then so this can be the city population. So this is an integer array population. Actually this is an array of size 5, right? So in that way then so we can assign allocate memory for 5 different locations. All right, now in here then when you allocate memory for this array, so this will be size 5, and then this will be size 5. So now suppose we read data for these two arrays. So then first one is city A, and then let's say the population is going to be 500. So second one is city B, population is 200, and city C has a population let's say 1000. City D has a population 1560. City E has a population 285. All right, now we need to find out the name of the city that has the largest population. Now in order for us to do that, so what we have to do is we somehow need to relate these two arrays. Now if you look at it, these arrays, so index 0 of the first array, that's a city name array, correspond to the index 0 of the city population array. So likewise index 1 of the city name array correspond to the index 1 of the population array. So since these data items are related to each other, so we call it a parallel array. So parallel means they have corresponding values stored in this array. Now if I want to find the name of the city with the largest population, so what I can do is actually, so I can get the index of the location where we have the largest population. So we already know how to find the largest value stored in an integer array. Now in here then, so this value, so that's going to be the index 3, will have the largest value in the population array. Now the corresponding city name should be then the index 3 of the city name array. So since they correspond to each other, so as long as we find the index at which we find the largest population, we can use that index to get the name of the city. So it's a pretty nice relationship among multiple array elements, where we have related elements stored in parallel arrays like this, right? So let's try to construct the program for it. So now the first thing is then, so I'm going to write the for loop for it, assuming that the arrays are already defined. Now then in the for loop, so what we do is for int I equals 0, I less than 5, because we are going to store 5 cities, okay, and then I plus plus. So what we do is then maximum index, so max index equals to 0, right? So then, so we can check if the population array max index is less than population array I. So if you find a location I that has higher value than the max index location, so then max index has to be the ith location, right? Now once you run through this for loop, so then max index is pretty much going to give us the location at which we find the largest population value. So then according to the previous description, we know that that particular index has a correspondent to the name of the city also. So then in order for us to display the city name, so what you can do is, so we can use a cout statement and then say population, and then we can go ahead and display the population. That's going to be the max index, right? And then you can display the city name. So it's going to be the city name array max index, right? So that will pretty much gives us the name of the city with the largest population as well as the corresponding population. All right. So then getting that information from the for loop help us for subsequent computations.